Welcome to DP Tutorials by Tony Jarwa. In this teaching module, you will learn on one topic, which is the electric potential and electric potential difference. So, in this teaching module, we will learn on the importance of this electric potential. So, we need to understand what is this electric potential. So, basically, electric potential is nothing but the amount of work done in bringing a charge from a certain point up to the point where the electric field is experienced. Now, when you look at this definition, it says, I have clearly written over here that electric potential at any point, at any point within the region of the electric field. We know that if I consider this as the source charge, if I consider this as the source charge, and this source charge will produce what? It will produce its own electric field. It will have its own electric field. Say if E is the electric field, so the electric field, since it is a positive charge, so it will be directed radially outwards. Now, if I assume that this electric field, that this source charge is located at point O, and the electric field of the source charge is up to point B. That means up to point B, that means you will either, if you bring a certain small test charge, see if I place this test charge Q0, at infinity. So if I place this test charge plus Q0 at infinity, that means since if we have a positive charge, and if we have also a positive charge, when two positive charges, we bring two positive charges to each close to each other, then we expect that there will be electrostatic force. And what type of electrostatic force? The type of electrostatic force will be a repulsion in nature. There will be some repulsion. Now, if I exert some amount of work done, or if I do some amount of work done on this positive charge, that means when we do something amount of work, when we do some work, we are moving the charge. And when we are moving the charge from infinity up to this point, that means you have to do work against this electric field. You have to do work against this electric field. See, this is the charge, and if I bring this test charge up to that point, that means I have to do some work. That work will be moving this charge from a point at infinity to the point B. See, another condition. Suppose if I take this test charge and bring this test charge up to this point. See, from this, this will be work done in moving the unit charge from infinity. See, this point, that small point over there is point C. But due to this point, there will be no electrostatic force. No electrostatic force. As you keep on bringing this charge, very nearer to the source charge, that means what will happen? More will be your electric field, or more will be your electrostatic force of repulsion. So in this case, that means this is the amount of work done. When you bring the test charge from infinity, from an infinite position up to the point where electric field is experienced, that is what is defined as our electric potential. So over here, the blue infinity B is the amount of work done in bringing the unit positive charge from infinity up to the point B. So now you have to represent that formula. What is the formula? The formula over here, it will be denoted by what? It will be denoted by V. V is equal to W divided by Q. In general, we write as W divided by Q, but in this case, you have to be very, very specific. You are doing the amount of work done moving the charge is from infinity up to point B, and we are bringing that charge Q0 against the electric field produced by this charge Q. Produced by that charge Q. So this is that working formula for the electric field, or for the electric potential due to the source charge. So we are finding the electric potential due to the source charge. Then next, we have to cater into the SI unit. So what is the SI unit of electric potential? We know that SI unit of work, the SI unit of work, it is always in terms of in terms of joules, and the SI unit of charge, it is always in terms of it is always in terms of coulomb. Okay? It is always in terms of coulomb or coulomb. Then from here, the SI unit of potential is just nothing but volts. Okay, this is similar as voltage. So the SI unit of electric potential is nothing but voltage, or we write as volts. What is this volts? That means 1 volt will be equal to 1 joule divided by 1 coulomb. We borrow the concept from here, 1 joule divided by 1 coulomb. So from here, when is electric potential said to be 1 volt? The electric potential is said to be 1 volt if you do work. Okay, if you do work on a charge having a magnitude of 1 coulomb. Okay, so when you do work on a charge, see if this charge Q plus Q is having 1 coulomb, and you do some work on this charge. Okay, you are doing some work on that charge, and that work will be equal to how much? This work will be equal to 1 joule. That work will be equal to 1 joule. Then that potential is defined as 1. Then potential is defined to be 1 volt. 1 volt. So electric potential, this note number 2 is very important. The electric potential of a positive charge is always positive. Okay, so it is always positive. The electric potential for a positive point charge is always positive, and for a negative, it is always negative. So over here, if I have a source charge which is negative, so the electric field lines will be directed radially inward. So these will be the direction of your electric field lines. So potential for positive charge is positive, and for negative charge is negative. Then now we will move on into this electric potential difference or electrostatic potential difference, or EPE. Okay? See, in this electrostatic potential difference, it is the difference between 2 points. 2 points within an electric field. Over here also, it is just the repetition of what we have done. This is considered as the source charge. Okay? This is considered as the source charge. See, at the source, let Q be the magnitude of the source charge. Then suppose at a certain points, okay, then if we have this positive charge, it is very clear that there will be electric field, and the electric field will be directed on that direction. Okay, on that direction. See, over here, if I consider 2 points, okay, if I mark 2 points over here, 2 points, okay, if I mark 2 points within the electric field or within the region of the source charge due to the electric field, then let these points be E and B. That means we know up to point A and up to point A and up to point B. That means the electric field due to the source charge will be experienced. More than this, in this region, there will be no effect. Okay? There will be no effect of the electric field. There will be no effect of the electric field. That is the main concept that we need to know. Okay? So in this case, we have to, again, in order to find the electric potential due to the source charge, we have to assume, or we have to take a unit positive charge. You always have to consider a unit positive charge. So in this case, let us take this point, and let at that point, okay, this charge Q naught is represented. See, this charge Q naught is at infinity. It is located at infinity. See, if you want to bring this charge from infinity up to this point B, up to that point B, you have to do a certain work. So let that work done in moving the charge from infinity up to point B be W, okay, be represented by W, infinity up to point B. Again, if you want to bring this charge very nearer to the source charge, you have to do more work. So this will be one. This will be that amount of work done in moving this charge from infinity. You are moving this from infinity up to what? Up to point A. Okay, up to point A. Up to point A. So there is a difference. There is a difference. So from here you have to do more work. It is evident from the figure that the potential at point A is more than the potential in moving the charge up to point B. Why? Because of the distance. So there is a difference in potential. So this difference in potential we derive as what? As WAB. Why WAB? Because the potential of the point A is at a higher potential compared to the potential at point B. So always when we write something like this, that means it should be from higher to lower. So from a point at a higher potential to a point at a lower potential. So from here, this electric potential difference between 2 points, this electric potential difference between 2 points is given by some expression. It is given by the expression. Suppose let V be that potential, and if V is that potential, then we write as in general we will write as W, W BA or WAB, WAB. WAB, work done in moving the charge between these 2 points A and B. So from here, this will be W VA minus VB. So what is the potential at point A? We know that the potential at point A, this VA, that VA will be equal to 1. W infinity A, work done in moving the charge, the test charge from infinity up to point A with respect to what? With respect to that Q0. And VB will be W infinity up to point B Q0. So if we use these illustrations in this equation, then we will get W infinity A, minus W infinity B, which is divided by 1, divided by Q0. So this is your one. This is your working potential, working formula for the electric potential difference between 2 points within an electric field. Or you can write in another format, which is VAB. VAB, it is equal to W, what I have written over here, WAB divided by Q0. What is this WAB? This WAB is the work done between 2 points. Work done between 2 points. This WAB will be equal to W. If you take this expression, W infinity A minus W infinity B. So this is the concept. This is the concept of electric potential difference. So electric potential difference is nothing but the amount of work done. It is the amount of work done. I've written over here. It is nothing but the amount of work done. What are you doing? More amount of work done in bringing or moving a unit positive charge against the electric field. It should always be against the electric field of the source charge from one point, from this point at a higher potential, from a point at a higher potential, from a point at a lower potential to a point at a higher potential. So WB will be a 1. WB is said to be at a lower potential, and WA is said to be at a higher potential, because when you move this charge, when you move that charge When you move this charge very, very close, when you move this charge very, very close to the source charge, that means there will be more electrostatic force. Okay? There will be more electrostatic force. Okay? More electrostatic force. So more will be either the force of attraction or either the force of repulsion. In this case, if we consider two like charges, positive, and over here also this is a positive charge, then there will be more repulsive forces, electrostatic repulsive forces. So remember that electric potential difference is WEB divided by Q naught. Okay? So SI unit will be the same. The SI unit of electric potential is your volts. Thank you.